Hello, welcome to Naming and Drawing Functional Groups. Today we're going to be looking at ketones. The ending of the word ketone has O-N-E as the ending. That is also the ending for any sort of organic molecule that has a ketone in it. So we would need the O-N-E ending to indicate that we have a ketone, and a ketone group looks like a carbon double bonded with an oxygen and then two other carbon chains on either side. This is called a carbonyl group here, this carbon with a double bonded oxygen, and it can never be on the ends. So on each side, there has to be another carbon chain, however many carbons long. So ketones can only be in the middle. So if we look at our first example, we have 1,1-dichloro, 3-ethyl, 2-hexanone. I would start by drawing the parent chain, which is always the last word of our name. Hex is 6 carbons, so I would draw 6 carbons there. And because it's AN, that means these are all single bonds in between those carbons. Now this 2 implies that we have a ketone on the second carbon, indicating the O-N-E ending. That second carbon has a ketone. On the third carbon, we have an ethyl group. Ethyl has 2 carbons in that group. And on 1 and also on 1, we have 2 chloro groups. So on the first carbon, there's 2 chlorines. The rest of these carbons can be filled in with hydrogens to make 4 bonds for each carbon. That's going from the name to the drawing. We've got another name to drawing example here if you want to pause it and try it out yourself. We're going to draw our parent chain first, pentanone. Pent has 5 carbons. I'm going to do a line diagram this time. We've got 5 carbons in that line. This 2 indicates that on the second carbon, there's an one group, which is a ketone group. And on the third carbon, there's a methyl. So when we do a line diagram, we can just represent it basically with sticks. And each of these points indicates that there's a carbon at that point. So 5 carbons in our parent chain and 1 carbon for the methyl group. If I were to draw this out in a structural diagram, that would be 5 carbons long, all single bonds due to that AN in the pentanone. On the second carbon, we would have the ketone, and on the third, we would have a methyl group. The rest would be filled with hydrogens so that they can all form 4 bonds. Notice I didn't put a hydrogen bond here because this carbon already has 1, 2, 3, and 4 bonds. So that carbon is already full. That's another example from name to drawing. Now this time, if we were to go from drawing to name in this third example that I have, we would want to start by numbering the longest chain. So I could go 1, 2, 3, 4. I could have dropped down here and called that carbon number 4. The chain would be just as long, so it doesn't matter which way you go. You do want this ketone group to be on the lowest number. So if I had started from the right side here, the ketone would be on 3, whereas if I start from the left, it's on number 2. So we want the ketone to be at the lowest number. We will start from the left side. And we also have a methyl group. So this C by itself is just 1, which means the group is called methyl. We will put that methyl in order, in alphabetical order first, with any other groups coming off the parent chain. In this case, I don't have any other groups, so I can write that one by itself as a methyl group. It is coming off of the third carbon from the parent chain, so we can show the location of that with a 3, and the ketone is at the second carbon on the parent chain. That parent chain is a butane chain because it has 4 carbons. However, because we have that ketone on the second one, we need to change the ending to O-N-E, and we know that ketone is on the second one because we put the 2 in front. 3-methyl 2-butanone. You could have also written it like this, butan-2-one. In that case, if you wanted to put the 2 directly after the one, up to you. Either way should be correct. So those are ketones. Let me know if you have any questions.